Right now, I will start talking about the application part. And first, we will introduce what we used for the application parts. And first, the rubber band and 2 bottles with water to simulate the mass. And 2 springs, 1 spring with 2 rubber band in parallel to a spring, and one is only 1 rubber band, and tape, and 2 coins to simulate the mass. We first used the coins to simulate the mass, but we found that the mass for the coins is too small that the waveform will change. In our initial condition, delta x2 is negative, and if the rubber band is compressed, it will not be flexible and won't apply force on the system, just like what we display in the video. As the result, we use the bottle with water to replace our coins. But at first, the bottle is too heavy that it will reach the floor, so we reduce the amount of water in the bottle until it reaches our ideal condition. So we use the springs that with 2 rubber band in parallel first, and as we can see, we think that there will be a square wave, but it will not be obvious because the oscillation is too small for us to see that. And there are the scales we want to move besides the spring. So we use the spring with only 1 rubber band to replace our first condition. And our initial condition is to set that delta x1 equal to 6 and delta x2 equal to -9. And for the oscillating part, we use the slow motion to see it's moving. And we focus on the second bottle. And we can see that when the second bottle goes to its top, it will stay a period of time. And when it goes to its bottom, it will stay a period of time too. And it just acts like the square wave we expected. But because of the friction of the bottle to the wall and the damping of the rubber band, the decrease of the oscillating amplitude is very quick and finally in equilibrium. We expected to do the triangle wave first, but the characteristic of triangle wave is not obvious. It's just like the sine wave, it just goes up and down. Not like the square wave, it stays a period of time. So we do the square wave instead. And this is all our presentation about spring circuit. Thanks for listening.